Welcome to our channel. Today we're diving into the cosmos to uncover some lesser-known fascinating facts about our celestial neighbors. From the rugged, cratered surface of the Moon to the swirling clouds of Jupiter, we'll be exploring the wonders of our solar system and beyond. Buckle up for an exciting journey through space. Our Moon, a constant companion in space, a silvery beacon in our night sky. For millennia, humans have gazed upon its face, woven myths about its markings, and even dared to walk upon its surface. But there's a side that remains hidden from our view, the so-called dark side of the Moon. The Moon is tidally locked to Earth, always showing us the same face. The far side experiences day and night, just as the side we see does. When we see a new moon, the far side is in sunlight. And when the full moon lights our night, the far side is in its own night. In 1959, the Soviet Luna 3 spacecraft beamed back the first images, revealing the dark side. Unlike the familiar face with its dark plains called Maria, the far side is a chaotic landscape of craters and mountains. It holds hints about the moon's formation and evolution. Venus, our celestial neighbor, often referred to as Earth's twin due to its similar size and composition. Shrouded in a thick, toxic atmosphere, Venus holds a secret beneath its swirling clouds, a secret that sets it apart from most planets in our solar system. Venus is a rebel, a cosmic oddball, because it rotates in the opposite direction to most of its planetary siblings. On Venus, if you could pierce through the dense clouds, you'd witness a sunrise in the west and a sunset in the east. It's a phenomenon known as retrograde rotation, and it makes Venus a fascinating outlier in our cosmic neighborhood. One leading hypothesis suggests that Venus might have started its existence rotating in the same direction as most planets, but something dramatic happened early in its history, a cosmic event that flipped its spin. Another theory proposes that Venus's thick atmosphere might be the culprit. Over billions of years, the gravitational pull of the Sun on Venus's dense atmosphere, combined with friction between the planet's core and mantle, could have gradually slowed and eventually reversed its rotation. Mars, the red planet, a desolate world of rusty red dust, towering volcanoes and ancient riverbeds. Mars is losing its atmosphere, a process ongoing for billions of years, stripping the planet of its protective layer. Unlike Earth, Mars's magnetic field weakened, leaving it vulnerable to the solar wind. Charged particles from the Sun slam into the Martian atmosphere, stripping away atoms and molecules. Evidence of this loss is seen in the thin Martian air, now about 100 times thinner than Earth's. This thin atmosphere can't trap enough heat to keep water liquid, making Mars the dry, dusty world it is today. Jupiter, the king of our solar system, a colossal gas giant adorned with swirling bands of clouds, a testament to the raw power and beauty of nature's forces. And within this tumultuous Jovian atmosphere, a storm of epic proportions rages, a storm that has captivated astronomers for centuries, the Great Red Spot. Imagine a storm so vast that it could swallow Earth whole, a swirling vortex of crimson clouds, a tempest that has endured for centuries, perhaps even millennia. This colossal storm, a prominent feature in Jupiter's southern hemisphere, has been observed for over 300 years, since telescopes first turned their gaze towards this distant giant. Early astronomers, limited by the technology of their time, could only marvel at the Great Red Spot's size and persistence, its true nature remaining a mystery. The Voyager missions provided our first close-up glimpses of the Great Red Spot, revealing its intricate swirling patterns and its massive scale. We now know that the Great Red Spot is a dynamic and ever-changing storm, its size, shape, and color fluctuating over time. Saturn, the ringed jewel of our solar system, a gas giant adorned with a breathtaking system of rings that has captivated skygazers for centuries. But Saturn holds another wonder, a secret hidden within its turbulent clouds, a geometric enigma that defies our understanding of atmospheric dynamics, a hexagon-shaped storm. At Saturn's North Pole, high above the planet's swirling clouds, lies a massive six-sided jet stream, a perfect hexagon etched into the planet's atmosphere. This bizarre atmospheric feature, first observed by the Voyager spacecraft in the 1980s, has puzzled scientists ever since, its origin and persistence defying easy explanation. The hexagon, a testament to the strange and wonderful workings of nature, is not just a fleeting atmospheric anomaly. It's a remarkably stable feature, persisting for decades, perhaps even centuries. Images from the Cassini spacecraft, which orbited Saturn for over 13 years, revealed the hexagon in stunning detail, allowing scientists to study its dynamics and evolution. Uranus, the ice giant shrouded in methane gas with frigid temperatures and supersonic winds. But Uranus harbors a secret: its extreme axial tilt. Unlike other planets, Uranus rolls along its orbital path. Its axis is tilted at 98 degrees, almost perpendicular to its orbit. This tilt has profound implications for Uranus and its seasons. For nearly a quarter of its orbit, one pole points at the Sun, the other in darkness. One hemisphere experiences a continuous summer day for 21 years, the other a long dark winter. Neptune, the 8th planet from our Sun, a world of deep blue hues and swirling storms, a realm of frigid temperatures and crushing pressures. But beneath its serene azure facade, Neptune harbors a secret. It's home to the most ferocious winds in our solar system, winds that would make even the strongest hurricanes on Earth seem like gentle breezes. Winds whipping across the Neptunian clouds at speeds that defy comprehension, reaching over 1,200 miles per hour, faster than the speed of sound on Earth. These supersonic winds, a testament to the raw power of nature, are one of the most intriguing and mysterious features of this distant ice giant. Unlike Earth, where the sun's energy is the primary driver of weather patterns, Neptune receives very little sunlight at its vast distance. Instead, the heat that drives Neptune's winds is thought to originate from within the planet itself, a remnant of its formation, or perhaps generated by radioactive decay in its core. Pluto, once considered the 9th planet in our solar system, is now recognized as a dwarf planet, a celestial body residing in the distant and icy Kuiper Belt. Despite its diminutive size and frigid temperatures, Pluto harbors a secret, a feature that has captured the hearts and imaginations of people around the world: a giant heart-shaped glacier. On a world shrouded in nitrogen, methane and carbon monoxide ices, a vast bright region stands out, its smooth surface resembling a giant heart emblazoned across Pluto's surface. This prominent feature, officially named Tombor Regio after Pluto's discoverer, Clyde Tombor, has become an iconic symbol of this distant world. It's a massive glacier, composed primarily of nitrogen ice, that spans a significant portion of Pluto's surface. The left lobe of the heart, known as Sputnik Planitia, is particularly intriguing, as it's believed to be a vast, nitrogen-filled basin, a frozen sea that might hold clues to Pluto's past and evolution. Scientists believe that Sputnik Planitia formed through a process called impact cratering. Billions of years ago, a large object, perhaps a stray asteroid or comet, slammed into Pluto's surface, excavating a massive crater. Ceres, a celestial wanderer residing in the asteroid belt, a region between Mars and Jupiter populated by remnants from the early solar system. Once classified as an asteroid, Ceres has risen in rank to become a dwarf planet, a testament to its unique features and scientific significance. And among its many intriguing characteristics, one stands out: evidence of a watery past. Ceres, it turns out, is not just another dry and barren asteroid, but a world with a potentially rich and watery history. This evidence for a watery past comes from a variety of observations and measurements made by spacecraft, particularly NASA's Dawn mission, which orbited Ceres from 2015 to 2018. One of the most compelling pieces of evidence is the presence of hydrated minerals on Ceres's surface. These minerals, such as carbonates and clay-like compounds, form in the presence of liquid water, suggesting that Ceres was once a much wetter and warmer world than it is today. Beyond the orbit of Neptune, in the frigid depths of our solar system lies a vast and mysterious region known as the Kuiper Belt, a realm populated by icy remnants from the early solar system, a treasure trove of celestial objects that hold clues to the formation and evolution of our planetary neighborhood. A vast and distant region, a cosmic donut encircling our sun, filled with icy bodies of all shapes and sizes, ranging from small, comet-like objects to dwarf planets like Pluto and Eris. The Kuiper Belt is believed to be a remnant of the protoplanetary disk, the swirling cloud of gas and dust that surrounded our young sun billions of years ago. While the inner regions of the disk coalesced to form the planets we know today, the outer regions, Beyond the gravitational influence of the giant planets remained a scattered collection of icy planetesimals. These icy bodies, preserved in the deep freeze of the outer solar system, offer a glimpse into the conditions that existed during the early stages of our solar system's formation. By studying their composition, orbits, and interactions, scientists can piece together the story of how our planetary neighborhood came to be. Thanks for joining us on this cosmic journey. We've explored some of the most fascinating and lesser-known facts about our celestial neighbors, from the moon's not-so-dark side to the mysteries of the Kuiper Belt. If you enjoyed these fascinating facts, don't forget to like, subscribe, and hit the bell icon for more amazing content. See you next time!